Alright guys, while I drink a beer, let's talk a little bit about what you were seeing me work on and how these things work exactly. So these are poor man's Mitee-Bite or Mitee-Bite Pitbull clamp. This is part one of 2 videos, but the way these are designed is the first thing you saw me do was cut a hole, drill a hole rather, at about 8.5 degrees off axis. And that's so when this bolt fits in here, it kind of fits a little bit like that. So a little bit of an angle. And then the way these work, and these aren't that expensive, I just decided I don't have very much money at all, so I decided to go ahead and build these myself, and I didn't think they'd be that hard. They're not as pretty as theirs. Theirs are thicker and countersunk, so the head of this bolt fits in there and doesn't show, and you don't run into it with your tool, but I just am using low profile bolts. This is a 1/4-20 bolt. This isn't the one I'm using, so that's part of the reason it's part 1, because I'm not gonna get to test these yet, but it's coming. So the way these work is you cut a hole about this size, but a little bit smaller. In this case, about 20 thousandths of an inch smaller, I think 25 thou, something like that. And so this gets put into the hole, and then if this was exaggerated, it kind of comes up at an angle like this when it goes into the hole. And then the material comes up like this, and then this thing is canted in there, and then when the bolt that's coming through here gets tightened down, it wedges itself in between it and it changes length from the X, so this way, by about 20 thousandths. It grows by 20 thousandths of an inch, 25 thousandths of an inch. So it'll press into the work, and it'll probably push into the piece that you're mounting this into as well. So the way this works, the order of operations, is you machine a part to hold the part, and then it's got recesses so it holds the shape of the part, and then it's also got a pocket for this, and then there's going to be a threaded insert that I'm going to put down at the bottom because I'm making this out of MDF. Normally they do, like in real machining, they do this out of aluminum, but I'm using MDF. And then that bolt tightens down and clamps into the workpiece and then holds that workpiece in place, and it's really low profile, just grabs at the bottom. They're supposed to work really well. People really like Pitbull, Mitee-Bite Pitbull clamps. So I made 3 of them, and then there's a radius I ground in on the back, and I was very careful to leave a little bit of blue because the design of this thing is dependent on this being 1 inch, and this is like within a thou right here. So that had to be incorporated, or I would, because it's only compressing by 20 thousandths. If I ground off part of it, I would lose that. So I kept some blue there, and this is rounded so that it kind of rocks like that. And then this was ground in at an angle, and then a much steeper angle this way to kind of give this a little bit of a knife edge. I ended up simplifying the design of this profile a little bit from when I originally worked up in CAD, but this works. And so these all have that little knife edge there to really kind of dig into the part, hopefully, and do it. Now this is just a cold rolled steel, nothing too crazy, but it's much harder. It's got a much higher Rockwell than aluminum. Normally these would be made out of like a tool steel, something really hard and durable, but I'm only ever going to work with aluminum pretty much, so just use a cheaper material to go ahead and make those. And yeah, I think they're going to work. She'll have to come back for part 2 to see for sure. Like that. Oh, and the last thing that I didn't say is these go on here, and then there's an O-ring that's going to slip up underneath this and hold these together. And then that O-ring just holds these all together, so these are nice and removable that way. And then also, because if you get clamped in there, it's a lot of force in there, so there's not really anything pushing it back up. So the compression of that O-ring forces it back up when you release it, and then you can take your workpiece out. The nice thing about these is you can also pop in a new piece and put them in that way as well. So I made 3. I'm planning to only use 2. 2 of these are pretty bad out of spec, but hopefully they'll work. Alright, here in the very harsh lighting of the sun, you'll see I have these 2 pieces of aluminum that came. Let me get in front of the sun here so we can kind of see. I have these 2 half-inch pieces here, and then down here, which is exciting, is my 1/4-inch pieces. These are going to be turned into my Iron Man suit. This right here is the what these are made for, and these are going to clamp down onto the corners of these like this, and allow me to hold this. And what this is going to be is a fixture plate. I'm going to drill a whole bunch of holes in this that are going to be thread tapped at the bottom, and then machined at the top. And I have a modular, 2-piece vise clamping system that's going to be made with these, and that's going to be this. Made out of the square extrusion right here, and this giant chunk of 3x1 extrusion. So these will be moved back and forth on that. But before, and that's how I'm going to hold, that's going to be my work holding solution for most of everything. But before I have that, I have to find a way to hold that. And that's what these are for.